Hi, Christopher Brown here with Easy Breezy Math. Math tips for teachers. What I wanted to go over today is what is known as the Pythagorean theorem. Okay, so Pythagorean theorem is also what we like to call the right triangle theorem. It has to do with finding the missing side of a right triangle. And funny enough, usually when I talk to people that haven't taken math in a long time, adults, well, they always remember a squared plus b squared plus c squared equals c squared. They might not know how to use it, but they always remember that formula, right? But as you guys know, I like to do the math with no formulas. You may know that if you've seen a few of my videos. Every video I put up, you'll rarely or almost never see me put up a formula because what I'm going to do is I'm going to show you how we look at that concept intuitively and understand it so that when we understand it, we don't have to memorize a formula. We can just go right into getting the answer. Okay. So on the board here, I've got two triangles set up there and there. And before we talk about them, let's talk about what we've said for area. If you go look at my area videos, you may see things like this, my little 4x4 and 5x5. Okay. It's important that students know, or everyone knows, that when I say I square a number, I'm putting it into the shape of a square. So if it's a 4x4, the concept is how many little squares are in there. And I like to say that, I like to rhyme that. How many squares are in there? Here, 5x5, how many squares are in there? And you could actually just count them. 4 times 4 is 16, or 4 squared is 16, right? That's my 4 squared, 16. Here, 5x5 is 5 squared, which is, as we know, 25, right? So that's the concept we want to have when we say we're squaring a number. We're taking the length or the measurement of whatever it is, centimeters, inches, meters, things like that, and we're squaring it. Okay. So when I was taught how to do it this way, a friend of mine, Robert Vriesman, who taught me most of this math, told me how to go ahead and tell a story. Okay. When you're teaching students, teenage years, they like to hear these stories. They like to hear these things that goes on. And his story was about the old man at the beach who was writing triangles, right? He's writing triangles and he's going along with his group. And he's got a group of about 8 or 9. Well, one guy stays back, or gal, and she notices something, that if you take the squares from one side and the squares from another side of the two that make up the right angle, okay, if you take those squares and you add them up, they'll equal the squares of the third opposite side, the one that's opposite from the right angle. And the teacher notices this and it's amazing thing. They're like, wow, what an amazing discovery. Of course, you can always put more into your story. Kids love stories. So, but here, what does that mean for this one? Well, a 4x4, as we've just done, is, we know, 16. Okay, so if I have 4 here along the edge and there's 4 there, I know if I square it, there's 16 little squares in there. A 3x3 would be 3 times 3, which is 9. 3 squared is 9, which means there's 9 little squares in there. And if we add that up, 16 plus 9 is 25. I know there's 25 big squares in there. And if there's 25 squares in there, the question becomes, well, how many are along the edge? And if it's all along the edge, we'd say, okay, that's a 5 by 5. And I've just found the missing third side, okay, without using a formula. A lot of explaining to do, but at the same time, you want your students, your pupils to be able to understand this stuff here cerebrally and go ahead and be able to memorize it and take it in as a part of their normal knowledge, not something that they have to say, well, wait, I can't do it unless I have the formula or I memorize the formula first. Not that important. What's more important is understanding the math. Okay. So here, let's do another one. 12 by 12. Now, again, it's also good to have them memorize squares as soon as possible. You're going to use them so much in math, all your perfect squares, you want to have them memorized. For some reason, students always get this one. They like this one, 12 times 12. Maybe it's because the biggest number we go to and they want to have the hardest one. We know that is 144. Okay, so if it's 12 on the edge, 12 by 12, 12 times 12, or 12 squared is 144. 5 by 5, okay, we'll do that one again. And 5 by 5, we know it's 25. And then what we'll do next is we'll add those up. 4 plus 5 is 9. 4 plus 2 is 6. And then the 1, we'll bring that down. We have 169 squares in there. Okay, so I have my right triangle with one side, the two sides that make up the right angle. They are going to be squared and added together. Once we do that, we'll use that for our third side, which is the side opposite the 90-degree angle, which is also our longest side, which is why we add to get it, and we'll get 169. Now, 169 little squares in there, how many are along the edge? We think about that. I take some guesses there. I like to ask them, well, what do I multiply when I to get 9? What number will I square to get 9? And that's their clue with the 3, right? So 3 times 3, but it's much bigger than 12, or it's bigger than 12, not much bigger, but bigger than 12. So it's 13. So that means there are 13 little squares here along the edge, and I found the third side. Okay. This is a great way to do Pythagorean theorem or right triangle theorem without having to even memorize one of the easiest formulas we have in math, which is a squared plus b squared equals c squared. All right. Hope you enjoyed the video. If you did, go ahead and put a little like there. There's always more things that you can do with this. Of course, there's more numbers. We want to do some where we have to subtract. Lots and lots of practice. But again, I'm going to go ahead and end this video here. If you like it, go ahead and like, subscribe, watch out for my next videos on more tricks and tips to teach math the easy way. All right. Thank you.